Problem number 52 asks you how much oxygen gas you can get when you decompose 125 grams of a 50% by mass peroxide solution. So this is a simple solution stoichiometry, or gas stoichiometry, where we have a pressure condition, we have a temperature condition. We're going to have to find the number of moles first. So if it's 125 grams of solution and it's 50% by mass, that means we're going to have half that mass of peroxide. So when you do that, you have 62.5 grams of peroxide. Now, whenever we're comparing two substances in a chemical reaction, what do we have to go to, kids?
Moles.
Moles. Yeah, that's right. So, if we have 62.5 grams, the molar mass of H2O2 would be 34. So if there's 34 grams per mole, how many moles is this, Jen? No pressure.
1.84.
1.84 moles of oxygen gas, of H2O2 are decomposing. So, from our balanced chemical reaction, we can find that we get 1 mole of oxygen for every 2 moles of peroxide. So we get 1 O2 for every 2 peroxides. So we would basically just cut that in half, and we would say it's 0.92 moles of oxygen being created. So, if I know the number of moles, I know the pressure, and I know the temperature, I can use Pivnert. It's not Pivnert. There's no R there. And we can find the volume. So the volume is going to equal to the number of moles. Don't talk while you're writing, it's bad for you. Divided by the pressure. So, first thing we need to do is convert this to atmosphere. So what does this become, Jen? How many ATM is that?
0.98.
0.98 atmospheres of pressure, and this becomes simply 300 Kelvin. So all we have to do now is plug this into the equation. So the volume is going to equal to the number of moles, which is 0.92, times our gas constant of 0.0821, times our temperature of 300, all divided by our pressure of 0.98. When we plug this all into the equation, what do you get for your volume?
23.12.
23 point what?
12.
And that would be how many liters of oxygen gas would be generated from decomposing 125 grams of peroxide that's a 50% solution at those conditions.